Welcome to the session 2 of the day of this River Room 1. We have the End of Microservices, and we have Nicholas here is a staff engineer at VGW with 15 years experience across different range of industry. He's going to tell us more about why this is the end of microservices. Welcome, Nick, please.
Cool, good This is a microphone, and that's how microphones work. Good morning. Don't worry, I'm on your side. I have a love-hate relationship with microservices as well, so I'm just going to spend the next 40 minutes hating on microservices, which I assume what you came for. So before I start with all of that, I'd like to take a moment to thank all of our very wonderful sponsors that we love very much, along with Jia and her team, the fantastic DDD staff who worked really hard to make all of this possible. This room is brought to you by Microsoft, but maybe Jia's meant to say that, I'm not sure. So just before I start, I'd like to say that everything I say today is my own stinky opinion and does not represent those of my company. So as following on from Jia's kind introduction, I have worked professionally in software for about 15 years. I started very early. My umbilical cord was detached and then plugged into a random port on a computer. And it all went downhill from there. So I've worked in mining, telecoms, VR, et cetera. And inside of those things, I really had a habit of working on all the things. So that's all your infra bits, CI/CD, backend, databases, networks, blah, blah, blah. I don't do front end, so it's more like most of the things. I also don't do AI or ML, so now it's just some things. I do some things. And also, need to advise you that I'm not Jackie Chan. I'm just a friendly software developer, and I promise I am friendly. I'm going to tell you what the bestest practice is the bestest. I'm going to do that with my friend Best Practice, GPT. Oh, no wait. Yes. It's not best practice anymore because there's some bad things about microservices. So it's not good anymore. Instead, I'm going to go look for a new best practice. Oh, wow, what a shock. I was going to say modular monoliths. Oh, I haven't heard that one. I'm glad this is new. And serverless functions. Thank you. So, don't think it was called a monolith back then. It was just called code, like the code, the thing. Back in we were mostly a cost-centered days, and we just spent money, and who knows what we did. I don't know, there's all these nerds just over here typing, but whatever. And then we decided to make the code smaller, sort of. We split it up. I don't know, the squares got smaller. That's all I saw on the PowerPoint anyways. So, you know how that kind of went. Do some digital transformation. Our poor monolith get chopped into pieces. So, we broke off a few blocks. We had our, I don't know, what do people usually break off first? Like a payments service or a authentication service or something. Either way, that went pretty well. We had these things on the side, and it was nice. You'd have your team, and you'd kind of have this nice little thing off by the side, and it felt like it was all yours, and you're moving quickly. So why don't we just do it more, right? And all these services. And the cool thing about teams, about people, about society is that we all love to work together. We can all support and depend on each other. The problem is it's a bit, just, for proprietary sake and all that. Maybe we just support and depend on each other just a little bit too much. And suddenly they kind of stopped doing work. I mean, they kept doing the work, but they they got really hard to change. It's not just this version. Please don't split us up. So all of that autonomy, or that speed we were getting, was, we were losing. That was kind of being eroded away at, right? And throw high latency on top of that. They're not talking face-to-face anymore. We're talking over networks. I guess that was a mistake, and we're going to go back to monoliths. This actually led to, actually before I say that, a quick sneak peek at what's inside your monolith anyway. It's kind of the same thing, just with components, right? It's the same thing, but the Y is a bit shorter. So this led to the greatest invention, I think, of the modern time, which wasn't modular monoliths, but it was actually the perpetual digital transformation machine. By doing this, we could create infinite value and infinite revenue just by continuously going back and forth. Remarkable what we're able to do when we put our minds together. And we were promised all this other stuff, right? So we were promised, it's easy to scale out. It's independently scalable, right? You can make this square big and then this square not big. We were told we'd be able to move more quickly, you'd be more autonomous, and you'd be able to make changes more safely, because you weren't really, no, but it's kind of true, right? Your locus of change isn't as big. If you've designed it well, you're not affecting as many things. You're not going and change the whole world. So I don't really know too much about all this stuff. I'm going to reach out to someone who is a real expert. And I think the thing that makes me trust this person so much is that they are very wealthy. And the more money you have, the more good you are. Okay. So anyway, in 2002, Bezos sends an email to his company. All teams will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through these interfaces. There will be no other form of inter-process communication allowed. No direct linking, no direct reads of another team's data store, no shared memory model, no backdoors whatsoever. The only communication allowed is via service interface calls over the network. It doesn't matter what technology they use. All service interfaces without exception must be designed from the ground up to be externalizable. That is to say, the team must plan and design to be able to expose the interface to developers in the outside world. No exceptions. Anyone who doesn't do this will be fired. Thank you, have a nice day. I didn't add in that part, it's nice guy. So just going to zero in on a few key things that I want to talk about, because if I take these out of context, it's easier for me to sort of reshape it into what I want to say. So all teams will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through these interfaces. Does anyone think that's a bad idea? The only communication allowed is via service interface calls over the network. Very good. We will solve these problems by making the wire very long. So, we had, or for some of you, you will have a beautiful love ball of services. I think the correct term is big ball of mud. I will call it love ball. Now let's go into slow motion to see how that actually went down. Cool? That's not particularly strange. We get to service depending on a database. And, well, just for convenience sake, we will plug another service straight into the database. And another one. Now, the database is your database is going to start to get a bit harder to change, right? Any change you make, you need to go and check that hasn't gone and affected the other services. So that's not great. You would have seen that I've made it should be our left, from the service to the database, kind of has this thicker arrow. That was the service that actually originally owned that database. So I'm saying it has a strong dependency, more of a dependency on this database. And I'm just marking it as red to say, yeah, this is getting harder to change now. As a result, your connected service that owns that database is also going to get a fair bit harder to change. To change functionality, to add functionality, you might need to change or add some tables. And if those are being depended on by these other services directly, you're in a bit of a bind, right? You're going to have to organize some sort of downtime, or maybe you can do some clever deployment tricks to avoid that, but still, you're giving yourself more of a headache than you really need to. And just for some extra fun, yeah, these services might go, oh, we'll do the right thing. Or the service on the right will do the right thing, and I won't go straight to the database. I'll get it from this other service which hosts that functionality. Awesome. Now that service gets harder to change as well. And the service that's reaching out is now becoming a bit more fragile. It depends on the database for some of the functionality. Now depends on this new service for some of this functionality. There's changes in either of those can potentially break this, this service on the right. It's going to make it very difficult, or more difficult to make changes in that database and service. So, it continues, we add another service, and now, especially if you've got those servers, we just want to add a bit of extra functionality. We don't really have the time to build a new interface for it. You do actually kind of end up in this kind of situation where, because of all these changes against the database, and we don't really have time to do a really nice automated test suite, everything starts to become very fragile. As most of you will know, when you die in systems architecture, you die in real life. Fortunately, there's Tom Cruise in Edge of Tomorrow. So when he dies, he doesn't die. So I don't know, we don't die. I just want to put the picture there. So let's do that again, one more time. But I'm going to swap a service and database around. So we've still got it's the same thing, but I've just moved the database to the left, so I've got more right to, I'm going to go plug in all these things, right? It's so much better now, wow. So you have the same thing, right? If you're plugging a lot of, if you're plugging a lot of services into this service now instead of the database, yeah, that service is also going to become difficult to change. It doesn't get a free ride just because it's a service. I would probably contentious, but I would probably not necessarily differentiate database too much from service either, especially now that we're starting to see things like data products, where you are very intentionally exposing kind of a data contract. So, you go on, more things plug in, and you kind of get the same thing. That flame was left in there, my mistake. But the key thing is, it's the service now that has multiple dependents on it. And yeah, it's difficult to change. But if that's your interface, if that's your front door, instead of your database or an internal service, that is something that's a lot easier to deal with. It's something that you've intentionally put out there, and you know that, hey, you understand the responsibility, or you have that intent when you design that interface. You're saying, yes, I know this is the front door, I know that people are going to depend on it, I'm going to design it so that I don't go and have all of these features. I make it very clear, you're allowed to ask this from me. And you'll see our database at the left is quite happy, or relatively happy. If you're looking at your service interface, you can kind of, I want to make an analogy to it being sort of you and your team being given high-level goals as opposed to be micromanaged, right? You want to have a clear flow that your service supports, rather than, what can commonly happen is you go, oh, let me get this information, I'll post this over there, and I'll put this over there. It makes it difficult to change later because eventually every behavior of your system becomes part of your API. Not just the open API schema or whatever, but your bugs, even things like network reliability, latency, every observable behavior becomes part of your API, whether you want to or not. I didn't make that up, that was someone else. So, don't get any funny ideas. Don't do this. It kind of looks cool, it kind of looks like a sword. Yeah, that won't work here. I don't know what you'd end up with. I'd like to try it as a thought experiment, but I think there's no way. Actually, some companies will kind of have something that looks like this, but they may have a very complex domain that requires a whole lot of internal services. That won't be true for most of us, or just by having a really long, I don't know, pipe. Cool. So actually, I think we're getting better at this, and a lot of us kind of get here and like, okay, we're going all right. That's kind of your month one, if you're lucky. As you start to grow out your system, as time moves on, it gets harder and harder to maintain a clear boundary. And I think that a lot of tooling came out, promising to, we'll make it go faster, or if you use this, you'll do microservices the goodest. But I think the problem lies elsewhere. So this is still, my advisor told me this is still culturally relevant. You basically have to fend off these guys, and I think for anyone who's spent some time in software engineering, we've all been this thing. So, wandering around, just hanging out in our office, or remote. Don't do that, please. Okay, that doesn't go there, but okay, fine. And it looks silly, but I think that anyone who's, worked in a sizable team for a while would have experienced this, right? Like, come on, help me out here. I've got a deadline. just one endpoint, brah. And that's kind of where it starts, right? So now it gets hard to change your database, and once you've not really, once that happens, it gets easier. Oh, I've already got a connection. Can we just add this on and that on, and big ball of mud is the ending. And we talked a bit about, we can use queues or, I don't know, like two cups on the street. It doesn't matter. I think a lot of those things, while helpful for physical decoupling of services, helped a bit reliability, but I don't actually think there's any tool that can really stop this from happening. Your best shot, unfortunately, or fortunately actually, is yourself. So what my opinion is that no matter what controls you put in place, so you can have your repository controls or your code owners, or maybe change approval boards or whatever, it doesn't really matter. What matters at the end of the day is someone who has a vested interest in maintaining sort of the city borders, right? So you need to maintain the structure and the architecture of kind of your boundary, of your systems. In a very literal sense, you'd very much, I think, the responsibility is on you to actually fight for your team's freedom. And sometimes that means, feeling like the bad person and saying no. But that is what needs to be done, right? And I'm deadly serious when I say I don't think it's too different to setting borders, setting boundaries in the relationships you might have in real life with your friends and family and whoever. So I've got the custodian now. Go on, get out of here. So looking back, I think what would have made my life easier is if I was a better custodian than I was, and if I didn't try to be the sus guy so much. It's difficult. You know, in the general case, you probably feel like you're probably like your team, and you don't want to say no, and you want to help them out. They might be having a tough deadline. Maybe they've misplanned. Maybe they haven't. But you've got an opportunity to just make that extra endpoint and get them what they need. And more often than being a custodian, I was that sus guy, right? I was desperate to get something over the line, and I would. What do? You message. You message the tech lead, or you message one of the developers. Say, oh, just prove this. Trust me, it's fine. So, I think one crucial thing is try to be more of the custodian and less of the sus person. There's business reality at play. Sometimes things need to go over the line. But I think the biggest thing missing from some modern teams is the lack of a custodian around that boundary. And if you don't define that boundary properly, and it's too broad, the custodian is looking over too much stuff, you're actually still going to get a lot of coupling within the internal services because they don't really have too much of an interest in they're focused on defend their boundary, not so much what's within it. Okay. Rich man. Repeating myself, all teams will henceforth expose their data and functionality through service interfaces. Teams must communicate with each other through these interfaces. I personally think this makes a lot of sense. There was one bit I cut out before that he said. All service interfaces, without exception, must be designed from the ground up to be externalizable. That is to say, the team must plan a design to be able to expose the interface to developers in the outside world. No exceptions. I think this is crucial. You will have your mindset will differ. If you're thinking about something as an internal service, you're going to think of it from the angle of, what can it do for me? You're going to give it very rich functionality. You might have it expose lower level functionality, right? So you might have it work with smaller level primitives rather than just providing a very generic front door. Don't know if this is a good idea. For example, you might just have it exposing, CRUD endpoints directly to your data model if you wanted to. I mean, that's basically what a database is, right? But you'll think very differently when you're looking at a service you intentionally meant to build as an external service. You know you're going to have to support it. You know it's going to take sort of very very varied requests, varied workloads. And when you think of it that way, I think you'll design it very differently. This is the front door. The strangers are going to come knocking. I'm just going to have this very clear interface, very intentional interface, supporting with the audience in mind. Whereas when you have an internal interface, I think you can be a bit more vague and be like, oh, I'd like to support this feature functionality. I think that's okay. So that's kind of a very simple visual version. You've got that internal service which is protected by an external service, and you'll be able to plug more things in that internal service because there are like external dependencies on it. When the dependency inside your team, you get a lot more freedom there, of course. And I can't stress this enough. Defend your autonomy. So, the one thing I was originally going to take issue with was this line, might be a bit hard to see up there. It says, the only communication allowed is via service interface calls over the network. I didn't like how he specified a physical, I guess, the transport here. I think it's less that it's less that we want to specifically say they have to communicate over a network, and more that I think the benefit of that was more like just communicate over a single protocol. Saying that we just want to have these services connected over a network, over networks, was I think it was really damaging. I think that had a really big cost. That was quite unnecessary. And I explain why. So it's kind of like this is a one I wasn't sure if I wanted to put in. Basically, the analogy I want to make, what I want to say later is, you start to see very common patterns. This is, for example, which is very simple, a layered application architecture. The importance is actually more on the data models and the relationships than these physical things, right? Whether it's talking over a network, or it's a service, or it's a database, or it's not a service at all, it's actually your domain code or your web routes or something. They all have relationships, and they all work with data. That's what matters more. I won't give away too much just yet. So, moving on, we were given a lot of promises about microservices, right? If you do a stinky monolith deployment, you would, you'd start deploying, and you'd crash, and yes, everything would go down. And that was one of the key selling points of microservices, right? So if you have a failed monolith deployment, you would lose all your functionality. You're fully down. Okay, so let's say we do independent deployments, and that fails. That's okay. It's only that single service that's gone down, right? So you've got all the interconnected services, and while, yeah, they might not actually crash because they are, I guess, physically isolated, you still have these dependencies, and even if you're able to degrade your functionality to sort of cut off that dependency on whatever's failed, you've still lost that functionality. That's not only like, wow, this is the best, this is absolutely fine. We just lost some functionality, that's all. We didn't get a crash. Great. Extra fun with microservices, we go back to deploying, and everything's fine. And then your other services still catch fire. So yeah, add an extra issue here. I think one thing I want to drill in on with this is that microservices came with, Bezos said his piece, and we had service-oriented architecture at the time. With microservices, like everything else, it came and there were good intentions, and there was a problem it was solving. And then it kind of turned into, as every technology does, a bit of a cult, right? Now there's rules. You need to do the holy things to do microservices right. You need to make sure all your services are independently deployable. I'm not going to actually, I think the way microservices was done created some of these problems, but I'm not going to blame it on the idea of microservices. And one of the key things I want you to take away from this talk is not to think about, these are microservice deployments, these are not microservice deployments. No, think about, if we thought of microservices as, these, don't share your data store, deploy independently, have a team that owns it. Those are actually the things that matter, and those are the sort of the knobs you can turn to suit what you're actually trying to do, right? To actually meet the needs of the team. If you find it easier to just deploy all at once, with your microservices, go and do that. You can do that by spinning up a full new environment and then doing a full cutover. It's a bit expensive, but you can do that. And there's benefits doing so. You now only manage a single version of your system instead of, and I forget the formula, but if you have 5 microservices all connected to each other and each can have n number of versions, that's a lot of different states your system can be in. It's much harder to reason about. You can mitigate it with things like contract testing and so on, but you're still making a headache for yourself, I think. So, I think, I don't know where this one's at. I think I've done probably over 100 interviews in my career, and I think one that comes up a lot is, well, one question I like to ask a lot is, why do microservices? One that comes up a lot is, scalability or performance. Performance is a bit odd, right? Because all you've done with microservices is make the wire a lot longer, right? You now have network latency to deal with instead of, just change the instruction pointer, an internal call is going to be on the order of microseconds or nanoseconds, as opposed to those very slow network calls, right? But on the other hand, if you say scalability, there was a little bit of mix-up here. Some people think that monolith means, you just have a single box and you can't horizontally scale that. Some people think it just means, you have a single big application. I think there was a mix-up there, and that's why some people said, it's easy to scale. I think one of the key points is probably independent scalability. So, okay, you can scale this one up, you can scale this one up, you can have them be different sizes. And we won't be contending on a single piece of hardware, right? So it's funny, we have all these microservices, they're all independently scalable, and they're all containerized, and then they're actually, they all ended up on the same, on shared compute hardware anyway. Of course, I'm being a little bit facetious. That became a lot easier with advancements in containerization and the associated tooling, right? With the C groups now, that stuff is very easy to manage. You can control, all your containerized processes are just given a slice of time and some memory, and they're fairly well isolated. So I think I've delivered on my promise. I just did about 30 minutes of hating on microservices. I don't know if that leads us anywhere. Why do we bother with all of this anyway? Were the people who pushed for it just silly? Was it all just a waste of time? The intent was good, right? At that time, I think a lot of us will remember you had these big legacy systems. And again, you might have had that big change approval board. It was hard to change things. You had to go through so many layers of review. Similar with the database, you had to go through the DBAs. So wouldn't it be nice if we could just, have our own little team, our own little village off on the side where we could do things the way we wanted to? And maybe we'll have a road going back to the capital so we can get what we need, but otherwise we have a lot of autonomy here. It was nice, and it actually made sense, right? The teams were doing this successfully. The teams were splitting off and building out their own villages on the side. They were able to deploy much faster and get results. There was definitely value out of it. The reason I say the networking, what Jeff said before about only communicating networks, why I take issue with that is that little difference in language, it's really highly contextual, I think. I'm using this to say, hey, when we were doing things in process, it was all very fast. I'm on the same machine, very quick. And we went to something much slower. which was one part of it. One cool thing I think is, one thing that was important with switching to communicating with networks was, of course, that we could now do, that was the only real way to do geo-redundancy. So now, obviously, we have, Amazon with AWS with their availability zones. You can have a degree of, geo-redundancy. You can even do cross-region, right? Of course, you have the cost of latency, but that was valuable. And I think quite contentiously, one that comes up is, often I hear, is the loss of transactionality, saying that you can't, you have one service, you want to save to the database, you want to save to the you want another service to accept that, but you want it to happen atomically. You want them both to happen or not to happen. There's patterns around that. We develop patterns around that. You could save an outbox table, right, to your database, where you have a table where you just have all these. You save those events first, and then you make sure that you can just have a process read off that and make sure that definitely gets sent to that remote service. More commonly now, you end up with two-phase coordination, which for those who don't know is kind of like it can be anything. So it's a thing that sits on the side and goes, you service, you database, get ready to store this data, and here's the data. And if the database is like, okay, and the server's like, okay, we can move on. But it was rather fragile at the time. You had that, now you have a new single point of failure, right? You've kind of killed off all that extra redundancy you get. But things move on. Technology got better, tooling got better. A very common pattern we see now is basically a replicated state machine driving that two-phase coordinator. So a bit technical, sorry, but where we had that single point of failure before, yes, we still have that single node that has to do everything. That's how two-phase coordination works. But it's now backed up by replicas, right? If you've used something like Amazon Aurora, where you've got a bunch of read replicas, you know if that the master fails, you can have a secondary node take over. We actually applied that to two-phase coordination. So now we can kind of do, transactions across network connected nodes. Fantastic. Yes, it's more expensive, it's slower, but you see this pattern everywhere now. DynamoDB does this, Kubernetes does this. We couldn't do that before, so I think that's where a lot of this, we can't do that transactionally. I can't make these calls to these two network connected things in a single, I can't make these atomic. I like drawing parallels to other things in technology. You can't really, by default, write to a single file atomically. That's probably unfair to say. For example, if you're writing multiple blocks, some disks may not be able to write that atomically. You're going to have, and many file systems do, have these journaled logs that do pretty much two-phase commit, or at least crash recovery. If I wrote the first block and the computer turned off, I need to be able to go, oh, that didn't quite finish. I'm not going to make that file visible. So I think if I can take a tip out of this is to say, if you do actually see all of these same patterns. Logs are everywhere, right? Your file system, nowadays in these distributed systems, it can help you kind of see past all this. That there's so much marketing marketing technology mumbo jumbo. If you actually look at those old stable patterns, logs, interfaces, it helped me gain a lot of clarity. So, I promised I'd say a bit about where we're going from here, but Sanjay's done it, taken one path for us and had a bit of a think about it. So for those of you who don't know, as far as I know, he is one of 2 senior fellows at Google. the other being Jeff Dean. He's worked on some small indie projects like TensorFlow, Spanner, and Protobuf. And I just picked 3 random ones. He's put out a lot of very impressive stuff. He released a paper, I think it was maybe a few years ago, towards the modern development of cloud applications. So him and his team did some research into, let's take stock and think about what we're going to do microservices. Not the clearest diagram. I snipping tooled this one directly from the paper. The key thing with this is, today, we still go, okay, I'm going to make a REST call or a gRPC call or a proprietary, use a proprietary protocol or whatever. Our software is still aware of this. Whereas I think logically, there was no need for that. All I wanted to say was, I have this, I want to make a call to this other service. And I want to have the data I require I want the request to have the right shape, but I don't care whether it's by, REST or carrier pigeon or, I don't know, letter in a bottle. Or you have latency concerns around that, but you cared more about the interface. So Sanjay's idea was to push all of that down one level. Now you have these servers which say, I want to talk to this service and I want to make these requests. And you would actually have an orchestrator, one level down, which would go and go, okay, well, you said you don't want, these are relatively latency and reliability tolerant. I'm going to go chuck them on some low-cost networks. Or these ones, these are really latency sensitive. I'm going to put these together on the same rack or in the same machine. But as a developer, all you'd be doing is going, okay, I want this to connect to this, and here's some attributes I might want to have. The really interesting thing about this is when cloud technology improves, and it does always improve, let's say, we have edge networks now. Let's say there was edgier, I don't know, gooder thing. You wouldn't actually need to change your application like you do now. You would update your runtime, and it would go, oh, actually, there's these new devices that are better suited for your application. Put these over here. Oh, and lower cost ones, and put them over here. The key thing here was, I think there was a lot of, we conflated the physical and the logical. We only want to talk between interfaces, but we ended up getting all that, basically formed a sort of like a meta coupling, right? We coupled our logical stuff to the physical stuff. So, if you want to make it not talk a network and bring it back into a monolith again, you're going to have to get rid of all of the, you're going to have to change your application. I'm running out of time. A lot of these things were really context. A lot of the decisions, when you look at the past and you don't have the context, can look pretty silly. You look at the context and decisions tend to be very contextual. That's why decision records are very valuable. At the time, they had much worse deployment tooling, so deploying was a bit more risky. Nowadays, we have things like, well, let me put it this way. We used to have a guy with a towel. Now we have a steering wheel. We've really moved on. We can do canary deployments now, so you can kind of pop up your monolith. Oh, that doesn't work. And never, majority of customers aren't affected. You're not going to fix this with Half-Life. You're not going to fix this with Rust. So stop thinking about best practices. Key points, really consider the boundary between logical and physical. Really consider the difference between an internal interface and external interface. Internal ones for your own team, external ones for unknown people who might depend on it later. And really think about, really focus on thinking about the audience of who's going to depend on it and who, not what. We focus too much on how big should a microservice be and what should my microservice contain. It's not about what the microservice is, it's about what you're using it for. easiest shortcut, just think about the team that you want to support this, the team that you want to run it, the people, and who's going to be consuming it. It could be the customer, it could be internal customers, but who's going to use it? What am I using it for? Do not get stuck on trying to identify things. That's our natural instinct. This is a blast service, or this is a blast service. This Finnish guy, I'm kind of repurposing what he said, but it's actually very similar. The key thing is focus on the data models and the relationships between them. The code is just, it's busy work. Focus on the data and the relationships. Thank you.